or internal field in solids. Local field or internal field in solids. You should be very careful. This is also very important question, as there are derivation parts. To explain it, much more time is required. So patiently cooperate with me. You know, to prepare yourself for how difficult it is. Okay, so to become it in easy, so it, and take a little bit of time. Okay, so right. Local or internal fields in solids. First of all, what is local field or internal field in dielectrics? What is the definition? This is a dielectric material. This is a dielectric material, dielectric slab like mica, okay, or glass, mica, glass or mica, mica, for example. Okay, if you apply a electric field E on it, if you from externally, from outside, you apply a electric field E. Yes, let us consider a atom A. In this atom A, let us consider a dipole. Is the dipole inside a atom A experiences the same electric field E as we applied externally? No. A dipole inside a atom A. Let us consider a atom A. In this, let us consider a dipole like this. Like this. This is a atom A. Here there is a dipole, plus minus separated by certain distance. Okay. Is this dipole inside the atom A experiences the same electric field E we applied outside? No. If this atom A experiences the same as applied electric field, then there is no need to discuss this internal field. Yes, this atom A experiences a extra field, some extra field E plus P by 3 epsilon naught. So this atom A experiences this electric field E plus some electric field. This field is called as a local field or internal field. So what is the definition? The electric field which a dipole experiences in a medium. So this is a medium, dielectric medium, and this is atom A. Inside there is a dipole. That dipole experiences a electric field. This field is called as what? Local field. It is different from applied field. Applied field is E, and this atom A experiences, or the dipole inside atom A experiences a different electric field from applied field E. Okay, so now let us consider the experimental arrangement. Yes, this is also very important question, right? Let us consider this is a capacitor plates. This is one plate of the capacitor. This is the another plate of the capacitor. So this plate of the capacitor is connected to battery positive terminal. This plate of the capacitor is connected to battery negative terminal. Due to this, negative charges are induced on the lower plate, positive charges are induced on the upper plate. Now between the two plates of the capacitor, I introduced a dielectric slab. I introduced a dielectric slab between the two capacitor plates. Now what happens? Due to these positive charges, negative charges induced on the top surface of the dielectric slab, and due to this negative charges, positive charges are induced, opposite charges are induced on the dielectric slab lower surface. You clearly observe there are two sets of charges here. One is positive charges on the capacitor plate, another one is negative charges on the capacitor plate. It creates a electric field E. This electric field E creates a electric dipole. What is the dipole? A negative charge, positive charge separated by some distance. Here on the top of the dielectric slab, negative charges are formed, and these negative charges got displaced in a direction opposite to electric field. Positive charges are got displaced in a direction of applied electric field. So due to electric field, negative charges on the top surface of the dielectric slab and positive charges on the bottom surface of the dielectric slab are induced. Right. Now these are the second set of charges. First set of charges are charges, positive plus charges and minus charges on the capacitor plates. Next set of charges is negative charges and positive charges on the surface of the dielectric slab. On the surface of the dielectric slab. Okay, now let us consider a atom A exactly at the middle of the dielectric slab. This is a dielectric slab, solid dielectric slab. In this dielectric slab at center, let us consider a atom A. Okay, this is atom A. Around that atom, let us consider a spherical cavity. Spherical. This is a spherical cavity. What is this spherical? Spherical cavity means a spherical shape. First of all, it is a ball shape. Around the atom A. Atom A is at the center. Around the atom A, let us consider a spherical cavity, sphere shape, spherical shape, like a ball shape. Exactly at the shape, center of the ball shape, there is a middle point A. This middle point A is an atom. There is an atom at the spherical shape center. Okay. Due to these negative charges on the dielectric slab upper surface, positive charges are induced. Due to these positive charges on the lower surface of the dielectric slab, negative charges are induced in the lower surface of the spherical cavity. So, is it clear or not? Once again, if it clear, then we will simply go to the derivation. There are three sets of charges here. Three sets of charges. One set of charges is positive charges and negative charges on the capacitor plate due to a battery. And another one is negative charges and positive charges. These are the charges on the slab of the dielectric. These are the negative charges are the charges on the upper surface of the dielectric slab, and positive charges are the charges on the lower slab, lower face of the dielectric slab. Okay, next, this is second set of charges. Third set of charges is positive charges on the upper part of the spherical cavity, and negative charges are the charges on the lower part of the spherical cavity. So these positive charges are due to these negative charges. These negative charges are due to presentation of these positive charges. Once again, these positive charges are due to these negative charges, and these negative charges are due to this positive. So opposite charges will induce in the same direction alternatively. So positive charges induce negative charges induce positive charges. Similarly here, negative charges induced positive charges here, positive charges induced negative charges here. Once this is over, it creates these three sets of charges, creates three electric fields, E1, E2, E3. So what is E1? This positive charge, this negative charge. You see this positive charge on the capacitor plate and this negative charge on the lower plate of the negative plate will create a electric field E1. Next, what is E2? This positive charge on the lower surface of the dielectric slab and the negative charge on the upper surface of the dielectric slab also creates an electric field. This electric field is called as what? E2. Next, what is E3 or E4? E3 I will discuss later. E4 as of now. Yes, a positive charge on the upper surface of the cavity and a negative charge on the lower surface of the cavity. Okay, it creates an electric field E4. So inside this dielectric slab, not only atom A, remaining atoms are there. Okay, those atoms will create the electric field E3. That we will see that. Okay, so what I told you is so the internal field at the atom site A. So atom A experiences these four electric fields. What are the four electric fields? Yes, this positive charge, this negative charge creates a electric field. This electric field is E1. It is experienced by atom A. Similarly, this positive charge and this negative charge also creates a electric field E2. This is also experienced by the atom A. Okay, and similarly, due to the this is a cubical dielectric slab. Inside this cubical dielectric slab, there are enormous number of atoms inside it. Okay, those atoms will create electric field E3. Okay, that also experienced by atom A. Next, what is E4? E4 is, this is plus charge, this is minus charge. It will create an electric field, and this electric field is from positive charge to negative charge. This also experienced by atom A. So atom A experiences four electric fields: E1, E2, E3, E4. We need to find out what is E1. We need to find out what is E2, E3, and what is E4. If we add E1 plus E2 plus E3 plus E4, the net electric field experienced by atom A will be calculated, and that is nothing but local field or internal field inside the solid. First, let us calculate E1. Field E1. E1 is the field intensity at A due to the charge density of the plates. So, how a E1 electric field will create? E1 electric field creates like this. E1 here, E1 electric field. Yes, E1 electric field is due to like this. Right, E1 electric field. So this is E1 electric field. Yes, right. So a positive charge and a negative charge will create a electric field. This electric field is nothing but E1 electric field. This is a positive charge on the capacitor plate. This is a negative charge on the capacitor plate. So this arrow mark is nothing but electric field. This electric field is E1. This electric field E1 is experienced by whom? Atom A. So now we have to calculate this E1. So already we have a formula. Displacement vector. What is the formula for displacement vector? It is epsilon naught times D is equal to epsilon into E. It is the formula for D. D is equal to epsilon into E. This is the electric displacement vector formula. That's why these definitions are very, very important. D is equal to epsilon into E. We can write epsilon as what? Epsilon naught into epsilon R into E. Okay. So here I am writing, here I am ignoring epsilon R, because here epsilon naught I am taking. Okay. So from this, what I can write, E1 is equal to D by epsilon. From this expression, what we can write is D is equal to epsilon naught into E. So from this, we can write E is equal to D by epsilon naught. But already we know D as epsilon naught E plus P. We have relation. We can represent D with what? Epsilon naught E plus P. So epsilon naught cancels out. So what it becomes? E plus E divided by epsilon naught. So E1 is equal to epsilon by P plus epsilon naught. Okay, P by epsilon naught. It's a simple derivations. E1, E2, E3. These are very simple derivations. Okay. Next, calculation of field E2. So next question is how E2 field will be created. How E2 field will be created. So this is E1 field. Now I am going to explain how E2 field will be created. Okay. E2 field will create like this. Yes. This is E2 field. Yes. Here a positive charge on the lower slab of a positive charge is there on the lower surface of the dielectric slab, and a negative charge is there on the upper surface of the dielectric slab. So the direction of electric field is from positive charge to negative charge. So it will create a electric field. This also experienced by atom A. So this is E2 electric field. So you clearly observe E2 electric field is quite opposite to E1. So here this is E1 electric field and this is E2 electric field. Yes. This is E1 electric field and this is E2 electric field. E1, this is E1 electric field and this is E2 electric field. E1 electric field is due to the charges on the capacitor plates. E2 is due to the charges on the surface of the dielectric slab, upper and lower surface of the dielectric slab. Here E1, E2 cancels out. Okay, so that means not cancels out. E2 is quite opposite to what? E1. So this is also called as a depolarizing field because E1 is quite opposite to E2, or E2 is quite opposite to E1. So we can write like this. We can write like this. E2 is equal to P by epsilon naught. Here, what is E1? E1 is equal to E plus P by epsilon naught. E1 is equal to E plus P by epsilon naught. But E2 is opposite to this one, and which means you can write E minus P by epsilon naught. Sir, why you ignore E? So this electric field you can neglect when you are calculating the electric field due to these charges too. So E1 is electric charge. E1 is the electric field due to the charges on capacitor plates. E2 is what? E2 is the electric field due to what? Charges on the dielectric slab. While considering the E2, you have to neglect other electric fields. So E is neglected. So plus P by epsilon naught is represented with minus P by epsilon naught because both the electric fields are opposite in direction. Okay, is it clear? Right. Right. Just be patient. You know how much difficult it is. Right. Field E3. So what is field E3? Just E1, E2, E3 are very simple. Just E4 is only the big concept. Let us see. E3. E3 is field intensity at A due to the other atoms contained in the cavity. We are assuming a cubic structure. So E3 is equal to 0, which means that, yes, let me explain. Yes, let us consider, this tube. This is a dielectric tube. Okay, this is a dielectric tube. Let us divide it into two parts. So this is, yes, this is the first part, this is the second part. Yes, here also atoms are there. Here one atom. Okay, here another atom. Okay, here another. Here also atoms are there. One atom, two atoms, three atoms. For example, yes, on the art, this is the center. At the center, what is there? Atom A. If you divide it cube into two parts, first half and second half. First half contains, let us say, three atoms. Second half also contains what? Three atoms. These three atoms will create electric field. These three will create a electric field in this direction, for example. Okay, these three will create a electric field in this direction. Okay, these three atoms also create a electric field in this direction. In this direction. Yes. So this atom A experiencing electric field due to nearby atoms, these three atoms, and this central atom A experiencing electric field due to these three atoms also. Okay, but net electric field is equal to 0 because left side three atoms are there, right side also three atoms are there. But three atoms produces plus 3 electric field. These three atoms create minus 3 electric field. Net electric field plus 3 minus 3 is equal to what? 0. So this is the net electric field experienced by atom A. Yes, sir. Why exactly you are assuming left side only three atoms, right side only equal number? Yes, that is due to the symmetry. We are assuming that we are taking a cubic dielectric slab, and the right side how many number of atoms are there? Right side so many, that many number of atoms. Right side left 50, left side 50, right side 2000, left side 2000. That is called as symmetry. So due to the symmetry, the electric field produced on the right side is equal to the left side electric field produced on the right side, and the same electric field experienced by atom A and net electric field experienced by atom A due to these atoms is equal to 0. So this is E3. What is E3? E3 is the electric field due to nearby atoms. Okay. Right. So you see here E3. E3 is the field intensity at due to other atoms contained in the cavity. We are assuming that cubic structure, so that net electric field minus 3e plus 3e, that is equal to 0. So net electric field experienced by the atom at the center is equal to 0 due to the nearby atoms inside the cubical dielectric slab. Last one is field E4, E4 electric field. So this E4 electric field is due to these charges. Which charges? These charges. So plus charge and minus charge. So what is the direction of electric field? Always the direction of electric field is from positive charge to negative charge. So E4 is the electric field due to positive charge on the top surface of the spherical cavity and a negative charge on the bottom surface of the spherical cavity. A positive charge, a negative charge separated by some distance will create what? Electric field. This electric field is E4, fourth electric field. Okay, the same I am taking. So our next task is to calculate E4. To calculate what? E4. This is very important question, and this is only the particular case where we have to use more mathematics. E4 while calculating E4. So to calculate E4, what I am doing is I am taking this spherical cavity in a jouled manner separately. I am taking this spherical cavity separately. Here I am taking the spherical cavity. This is the spherical cavity. Okay. So what are the charges presented on this? So here on the spherical cavity, positive charges and negative charges are presented. Here I am representing those charges on the surface of the spherical cavity. So negative charges, positive charges are okay. Negative charges, positive charge, negative charge. This side negative charges, this side positive charge. Right. Yes. Yes. Positive charges on one side of the spherical cavity and negative charges on the other side of the spherical cavity. Here you see. Here you see the same I represented. Okay. So negative charges are one side of the spherical cavity. Positive charges are on the other side of the spherical cavity. This is the atom A, central atom A. Let us consider a unit positive charge is here. What is here? A unit positive test charge Q is here. A plus Q is there at the center of the spherical cavity. Right. Now how to calculate E4? This is the situation. How to calculate the E4? Right. First of all, what is E4? E4 is the electric field due to negative charges and positive charges on the spherical cavity. It will create a electric field E4. Right. Now how to calculate? First of all, we will calculate what is the charge presented on the spherical cavity. What is the charge presented on the spherical cavity? Right. Here this is a spherical cavity. This is a spherical cavity. On the spherical cavity, what I am taking is a small area dA. This is a small area dA. I considering a small area dA. Okay, right. And it is making an angle theta with applied electric field. So this is the direction of electric field. In this direction of electric field, this x-axis is the direction of electric field. So with this direction of electric field, this line making an angle theta, and this line making an angle d theta. Sir, what is theta? What is d theta? Here I assumed an area dA. This dA area is extends between theta and d theta angle. So it extends between theta d theta with respect to x-axis or direction of electric field. Sir, next, what is our aim? So first of all, as what is the negative charge presented in this small area dA, I need to find out. What is the amount of the negative charge, minus charge? What is the amount of negative charge presented in this small area dA? We need to find out. So how to find it out? We have one formula. What is that formula? Charge is equal to P by A, polarization per unit. Yes, P polarization is equal to charge by unit area. This is one more formula. From this we can write that charge is equal to P into A. So we already know one particular theory. What is the theory? Polarization can be written as charge by area. From this we can write charge is equal to P into A. So here, if you apply to this particular concept, what it becomes? Q is equal to A. A means what? dA. It becomes what? dA. What is our area? In which area we need to find out the negative charge? In this area. What is the area? dA. dA is the area in which we need to find out the charge. And what is P? P is polarization vector. What is P? What is P? Students, be patient. Be patient. I am also very patient from last 2 hours. So to understand this concept, because they are derivation concepts, it requires much more imaginary things. Be patient. Almost it is going to complete it. Yes, I know it's a long session. Right. So P into A, instead of A, what I written? dA. In dA area of that particular area, I need to find out the charge. Into P. P is called as a polarization. Here, only P cos theta component is responsible for polarizing the charges in that direction. So here you see. Here. Right. Here, the area is dA and polarization component in this direction of dA is, so what is polarization? Separation of charges. Separation of charges is called as what? Polarization. So the negative charges are here, that is due to polarization. So the component of polarization is P cos theta in this direction. Yes, yes, you see P cos theta. Along this line, there is a concept called as P cos theta. This P cos theta is the polarization concept in this direction theta. Here, this is x-axis, this is x-axis, and this is a direction theta in which dA area exists. Okay, so the polarization in this particular direction theta is P cos theta. As force is a vector quantity. Force can be resolved into two components, F cos theta, F sin theta, in mutually perpendicular directions. F cos theta, F sin theta. So in the direction of theta, cos theta, F cos theta component is there, and in the direction of opposite to this, F sin theta is there. Likewise, polarization is also a vector quantity, and P cos theta is the component responsible for the separation of these charges. ఇది ఎక్కడి నుంచి వచ్చింది? From where you got it and all this, that is unknown, because already it is not unknown. It is not relevant for us because already this derivation is big derivation. Okay, so polarization component P cos theta component is responsible to separation of these charges in the direction of theta. So here what I am writing is Q is equal to, according to this formula, Q is equal to P into A. I am writing Q is equal to P cos theta into, in what area? dA area. I need to find out the charge. Right. Now, according to Coulomb's law, now let us reconsider this equation. Let us reconsider this situation. Here at the atom A of the spherical cavity center, let us assume a unit positive charge plus Q. Here a negative charge. Between negative charge, between positive charge, what exists? what exists? Attractive Coulomb force exists. Okay, so what is the formula for force? F is equal to Q1. This charge is Q1, this charge is Q2. Let us assume. Okay, this charge is Q2, this charge is Q1. This is plus Q1, this is minus Q2. So there exists a attractive force. Q1 Q2 by 4 pi epsilon naught R square. What is R? R is the radius of this small spherical cavity. What is this R? You consider this small r is the radius of the spherical cavity. R is the radius of the spherical cavity. Obviously, the distance between the negative and positive charge become what? R. So, this is a positive charge and this is a negative charge. The force of attraction between these two charges is equal to Fr. Resultant force between these charges is equal to Q1 Q2 by 4 pi epsilon naught R square. So, first charge is where? At center. At center. What is the magnitude of charge? Plus q. Plus q. So q1 is equal to q. What is q2? Q2 is the charge, negative charge presented in the small area dA. So what is the charge we find out as? We find out the second charge q2 as p cos theta into dA. So q1 is equal to q. Q2 is equal to p cos theta into dA divided by 4 pi epsilon naught r square. Okay, right. Now the area dA is calculated. Next step is how to calculate this area dA. How to? So yes, FR is not simplified because we don't know the dA. Our next task is to calculate dA. So what is dA? dA is, how to calculate dA? dA is the area of this. Yes, this is dA. Yes, this is the area of this small area is named as what? dA. How to calculate dA? Yes, to calculate this, let us construct a figure like this. Yes, let us extend like this. Let us extend like this. Okay, then if you extend completely, it become a circle. Yes, this is half circle. You know, this is half circle. Okay, if you complete like this, okay, let me draw it. You can understand. If you complete it, it become a circle. Yes. If you complete it, it become what? Circle. Circle with what area? dA. What is this area? dA. So this is a circle. I consider a circle with radius dA. Okay, now I need to calculate what is the value of this dA. But how to calculate the area of a circle having some thickness? But what is the thickness? You know, this is not a perfect circle. Perfect circle means it doesn't have any thickness. But this circle having some thickness also. This is the thickness of the circle. This is the problem here. So this is the problem here. How to calculate this? This is a circle with some thickness. First of all, we will calculate what is the thickness of this particular circle. Okay, right. Right. Let us consider this particular cone. This is the cone. Yes. Right. Let us consider this. Let us consider this cone. Only this cone. Let us consider. Here I am taking it separate. Yes. Here I am taking this cone separately. Yes, it looking like in what shape? Cone shape, and the angle is d theta, and the arc length is r. Then obviously, sorry, this is the radius. R is the radius, and d theta is angle. Then arc length becomes what? R d theta. So r d theta. So this is r d theta. R d theta is the thickness of this particular r d theta. So here the thickness is r d theta. R d theta is the thickness of this circle. Okay. Now how to calculate its area. This is a circle with r d theta thickness. Then how to calculate its area? Simple. It's a circumference. Okay. It's a, yes. Now calculate its area is very easy. dA is equal to circumference into thickness. Circumference, you know thickness. Thickness is equal to r into d theta. How you calculate it, sir? I am calculating by using this figure. So in this figure, if I calculated this part, if I take in consideration into this part, d theta is the angle and r is the radius, then arc length, it's like look like a cone, and the arc length is equal to this radius into angle. This is the arc length, r d theta. So r d theta is nothing but thickness of the dA area. Okay, so it is very clear. Thickness is equal to r d theta. Here instead of thickness, what I written? R d theta. Next, circumference. What is the formula for circumference of a circle? 2 pi r. Actually, circumference of a circle is what? 2 pi r. But this is not a circle. You clearly observe. This is not a pure circle. You clearly observe. You clearly observe this. This is not a pure circle. To take its area as 2 pi r, it's a circle with certain thickness. For this purpose, how to calculate its circumference? Yes, let us consider this triangle. So Q, this triangle, you take this triangle. You take this triangle. I extended a line. What is this? This is a this is the radius of this circle. You see, this arrow is radius of this circle having thickness r d theta. R d theta is the thickness of this circle, and this is the radius of this circle. Okay, so then how to calculate the radius? By using Pythagoras theorem. You take this triangle. Yes, separately I taken this. Yes, I taken this triangle. A, B, C, something like that. So theta is equal to what? Sin theta is equal to what? Opposite side. Opposite side unknown by hypotenuse R. So opposite side is equal to what it becomes? So sin theta is equal to what it becomes? Sin theta. Sin theta is equal to opposite side divided by radius. So opposite side is equal to what it becomes? R into sin theta. So r sin theta. So this value, ante the radius value is equal to r sin theta of this circle. So we calculated. Yes. I taken this triangle. I taken this triangle. Here the angle is theta. From this triangle, sin theta is equal to opposite side divided by hypotenuse r. So opposite side is equal to what? What is the value of opposite side? So r into sin theta. So the radius of this circle having some thickness r d theta is what? R sin theta. So what is its circumference? 2 pi into its radius r sin theta. So its circumference becomes 2 pi r sin theta, where r sin theta is the radius of that circle having some thickness into thickness of r d theta. So 2 pi into r is equal to what? R square sin theta into d theta. Okay, right? So now Fx. Now the force acting along the direction of the applied field. Fx is equal to Fr cos theta. Yes, we resolved Fr into two components. Yes, the here plus charge is there, here minus charge is there, negative charge is there, positive charge is there. A resultant force exists between a negative and a positive charge. We can resolve these force into two components. Fx in this direction, this is the direction of Fr, resultant force, this is the direction of force. Okay, so here I have annotated, I'm using the pen. So this is the direction of force. Actually force from positive charge to negative charge. Okay, so this is Fx and this is Fy. Fy. So I am resolving the force into two component. One is x component, another one is y component. Fx, x component of force become what? The resultant force is Fr. So Fr cos theta, Fr sin theta. So this is in this x-axis direction Fr cos theta, in the y-axis direction Fr sin theta. Yes, Fr sin theta does not responsible for the polarization of the charge. This negative charge on the surface of the charge and positive charge on the spherical cavity is not due to sin theta component. It is due to which component? Cos theta component. Why? It is in the direction of electric field. The force which is in the direction of electric field is responsible for the separation of charges. That's why we consider Fx component. Fx is equal to what? Fr cos theta. So Fx is equal to Fr cos theta. Almost it is about to complete. Be patient. Yes. Fx is equal to Fr cos theta. Fx is equal to Fr. Already we calculated resultant force. What is the formula for resultant force? Previously you see Fr is equals to Qp cos theta into Fr is equal to Qp cos theta into dA by 4 pi epsilon naught R square. So here right. Instead of Fr, what I written its value Qp cos theta into dA by 4 pi epsilon naught R square cos theta as it is. Cos theta as it is. Right. So Fx is equal to Qp cos theta into dA divided by cos theta. Its value Fr value is this one. Qp cos theta into dA by 4 pi epsilon naught R square is the value of Fr into cos theta. This cos theta is there. So cos theta into cos theta is equal to cos square theta. Right. So Fx is equal to Qp cos square theta, Qp cos square theta divided by 4 pi epsilon naught square divided by 4 pi epsilon naught square into dA. But we know the value of dA. What is the value of dA? So the dA value is 2 pi r square sin theta into d theta. Substitute that value here, 2 pi r square into sin theta into d theta. So instead of this dA, substitute that value, 2 pi r square sin theta into d theta. Right. So QP by 2 ones, 2 twos. So 2 pi cancel, okay, and epsilon naught, okay, r square cancel. So QP by 2 epsilon naught into what else? Cos square theta into sin theta into d theta is there. This is the a force acting along the x-axis or in the direction of electric field. Okay. Yes, is about to complete. Be patient. Fx is equal to Qp by 2 epsilon naught into here. What I need to calculate? So this is the force acting along x-axis due to the charge presented on this area only. You see very clearly. So a negative charge is there. A negative charge is there in this area. Due to this charge, a force, yes, a force Fx, a force Fx acting in the x-axis due to this negative charge. But I want to calculate what is the force acting along the x-axis due to the entire negative charge and entire positive charge on the spherical cavity. What is the force acting along the x-axis due to the positive charge and entire negative charge, entire charge? So we need to integrate the above equation from 0 to pi. One minute. Right. Yes, what you need to do to calculate the force, yes, to calculate the force, entire force, you need to integrate the equation from 0 to pi. So we are integrating the above equation from where to where? 0 to pi. So by doing integration, this is already big derivation, no need to remember all these things. If you want a derivation, the integration, yes, here it is there, you just go through it. Just 0 to pi cos square theta sin theta d theta integration is 2 by 3. How it came? So I derived here. If you want to see, you just take this reference. 2 by 3. So integration of cos square theta sin theta d theta from 0 to pi is 2 by 3. So here 2 cancels out. So what it becomes 2 by 3 by 2 by 3 epsilon naught. But still, but still we are not able to get. But still we are not able to get E4. What we have only Fx. Force acting along the x-axis due to the entire charge presented on the spherical cavity. So then how to get E4? You know F equal to EQ. So we know F value. F is equal to EQ. So F from the expression F is equal to EQ, you can write E is equal to F by Q. So F we know Fx divided by Q will use the E4 because F is equal to E into Q. So E4 is equal to Fx by Q. So Fx value is Qp by 3 epsilon naught, it whole divided by Q. Q cancels out. So E4 is equal to P by 3 epsilon naught. So what is the total internal field? It is the sum of E1 plus E2 plus E3 plus E4. So E1 value is E plus P by epsilon naught, E2 value is minus P by epsilon naught, E3 is 0, E4 is just we got P by 3 epsilon naught. So what is the value of E4? Plus P by 3 epsilon. Here we got plus P by 3 epsilon naught as E4. Similarly, we calculated E3 as what? 0. Similarly, we calculated E2 as minus P by epsilon naught. Similarly, starting E1, we calculated it as P by epsilon naught. So plus P by epsilon naught minus P by epsilon naught cancels out, and EI, local field or internal field, is equal to E plus P by 3 epsilon naught. So this is the expression for what? This is the expression for internal field or local field.